We also get quite a bit of AI notes here as well, so you'll just see that in the chat. All right, I think we are going to get started, everyone. Welcome to the final 1-inch workshop of the day with Caleb. Oh, let me see. Oh, there you go. You disappeared from the screen there for a second. Oh, I
Modified
think
job.
you're,
Sorry about that.
yeah, no worries. I'll let you get your presentation back up, and I'm still actually admitting people, so this is perfect.
Yep.
All right. You guys are in good hands now with Caleb. I will be in the background if you need anything, and have a great workshop.
All right. Hello, everyone, and welcome to the limit order protocol presentation. And so I'd like to start out basically explaining what a limit order is. And it's just an order to buy or sell an asset at a specific market price or better. So users can set it at whatever price they want, and it should fill at or near market. And this also kind of goes into what exactly are intents. And so intents are just planned actions aimed at achieving desired goals. And intent-based architecture is basically a way to design these tools and use DeFi that focuses on what users want to achieve rather than how they want to achieve it. And so with the limit order protocol, you can actually do intents. And this is what Fusion and Fusion Plus are based off of. And so I would like to kind of next outline exactly what the benefits are over like an AMM for order books or limit orders. And so with liquidity-based DEXs, you kind of have prices defined by formulas. So like Uniswap v2 is X times Y equals K, some constant product. And with an order book-based DEX, you have this kind of pricing defined by the order maker, and it's only executable under strict conditions. For liquidity-based DEXs, you usually require liquidity providers to actually provide this liquidity, and it usually needs to be profitable to kind of incentivize this provision. For order book-based DEXs, you don't need liquidity providers because that is what all the makers are, but instead you need just anyone to participate in it to both buy and sell. So both makers and takers. And without counterparties, no trades will actually occur. With liquidity-based DEXs, you have the possibility of price slippage, and also you have impermanent loss for the liquidity providers. Whereas with order book-based DEXs, the price slippage is less significant since orders fill at some exact rate. But you do have the issue of longer wait times. So if your price varies from market, then it's simply not going to fill. And so what about the limit order protocol developed by 1inch? Well, it's quite flexible. And this is how the intents were built off of it. It has support for ERC20, ERC721, and ERC1155 tokens. And so you can actually trade NFTs with it. You can also set up a set of custom rules and conditions for your trades. And this is where Fusion and Fusion Plus have actually been built on top of it. It also supports many different order types, such as stop loss, take profit, Dutch auctions, and also just standard limit orders. And also natively, it supports partial fills, fill or kill, and RFQ style orders. As for gas efficiency, the RFQ model has kind of been developed in such a way that it's fully like gas optimized. It's almost as simple as just transferring tokens between two parties. There's also just individual per order settings natively built in. You can also batch cancel orders in just a single transaction. through the nonce, which I will get into more detail later on. And there's also just minimal on-chain storage logic. So the orders are stored off-chain primarily, and then whenever they're filled, a transaction is sent, and it's pretty much just transferring funds between two different parties. It doesn't really store too much data on-chain. And so off-chain order creation, no gas required. Additionally, it does support permits and Uniswap's permit 2. So you can actually create fully gasless orders with no native asset. And so here's kind of a diagram of how everything works. The user will go and they will create an order. They sign it with their private key using the EIP 712 standard, and they will send it to our order book. And this order book is just a centralized database that stores the orders off-chain. And Resolver, if they're profitable, doesn't actually pay any gas fees. It's all work on the Resolver. And so here are some use cases that I've outlined that we might want to see during this hackathon. One of them is a gas station. So like I said before, you can create orders completely gaslessly. And so we would love if users could initiate a swap to the native asset of the blockchain and repay the lender via extensions. Also, potentially there could be vesting payouts. And so this could be a P2P style order where only a portion of it could fill at a given time. Also, time-weighted average price orders. So take one order and only allow a specific set of volume to fill over an extended period. We also would love to see grid trading. So like some automated buy low, sell high strategy by implementing some set of sequential orders. And also, most commonly, what we have seen is stop loss and take profit. So basic and range orders, so it can fill at a larger price range. And so now I'll get into some of the native features. This doesn't require any additional work on your end. And this is kind of the maker traits. So if you look at the order structure, one of the actual fields is the maker traits. And this is the settings that the makers want to actually allow or disallow. So the highest bits of the maker traits is toggleable flags. These are basically a way to disable certain aspects of the order or enable them, like disabling single fills, disabling partial fills or enabling them, requiring a pre or post interaction, which I will get into later, using permit 2, or wrapping or unwrapping ETH at the end of an order. And also the order structure, it does have the custom recipient field in case you need some external receiver to get it instead of the maker, and also the salt. And the salt can be used in a couple different ways, but primarily it is to avoid hash collisions. This is so you can cancel individual orders and then have another order with similar fields or the same fields to be filled again. And I also didn't mention it, but the extension, although it is part of the order, it is not actually part of the signed data. Instead, this is what the salt is for. The salt has to be a very specific format. This is primarily handled by the SDK, but if you want some more information, please reach out on Discord. And so this extension includes a couple different fields. And these are what you're primarily going to be working with during this hackathon. And so you have the maker asset suffix and the taker asset suffix. These are just particular little information bits that you might need about a maker or taker asset for an order to fulfill. And this could be like decimals for precision or something else. There's also the making amount data and taking amount data. And so this is a way to actually get some price information to dynamically change the rate. So for example, with a range order, you might want to use Chainlink or Pyth to compute a specific making or taking amount. Examples of this usage can also be seen in our Dutch auction calculator in our GitHub repository. There is also the predicate, which I will be going into more detail later on. And this is basically just a true or a false statement. If it's true, the order can fill. If it's false, the order will fail. There is also the maker permit, which supports either standard ERC20 permits or permit 2. There's also pre-interaction and post-interaction data. And this is going to be some action before or after a swap. And so before a swap, it might be something like unwrapping Aave tokens. Or after a swap, this post-interaction could be like unwrapping Ethereum or taking a fee. And lastly, there's custom data, which is just some external call which doesn't do anything to affect the order itself. So getting into predicates, it has a very specific structure, just like most of the extension fields. And so the first 20 bytes of the predicate is just the target address. Usually this will be the 1-inch limit order protocol address. And then the rest of the data is just ABI encoded data. And so some of the built-in operators in the limit order protocol are things like greater than, less than, equal to. There's also and or operators. And so I've kind of set up an example structure in the bottom left here. You can see kind of encoded, you would have this and checking if both the conditionals are true. And this or structure, you have two greater than statements inside of it. And so if that resolves as true, then it will check the right-hand branches. And so as an example, you might have this predicate check if the rate of the limit order is greater than the Chainlink Oracle price. And so you can see the encoding is heavily nested with ABI packed encoding. And so the SDK will do a lot of the work for you. But again, if you need some more help or information on this, please reach out in Discord. Another advanced feature is interactions. So the standard execution flow is the maker's pre-interaction. And this is something the maker wants to do beforehand. Like I said before, it could be like unwrapping Aave assets. And then once this pre-interaction executes, the maker's funds will be transferred to the taker. And then in the middle of the transaction, while the taker has the maker's funds, there's this taker interaction. And this could be something like swapping the maker's assets or doing something else, like readjusting positions or just anything the taker wants to do. And then once this settles, the taker will have their tokens removed from their address and sent off to the maker. And then once this actually settles, the maker's post interaction will execute. Like I said before, this could be something like taking a fee or doing some other action like wrapping or unwrapping wrapped ETH. And as you can see, the structure of the pre and post interaction is also very similar. So the first 20 bytes is the target, and then the rest of the bytes is some ABI encoded call data. The next feature that I'd like to talk about is the amount getters. And so these are a standard interface to kind of get a rate. So the problem is, like most static orders are very limited in functionality, might become stale. And so the solution is these getters. So in real time, you can actually calculate the exchange rate uh, that you might want at time of order filling. So as an example, this is kind of the Dutch auction that we have in our limit order SDK. And so how it works is you would be developing a contract with the interface IAmountGetter with get making amount or get taking amount, and it will return a UNT256. And this is the actual amount that the user's taker or making amount will be set to. And so again, the structure is quite similar. The first 20 bytes is the target, and the rest of the bytes is some encoded call data. And so this call data can be handled by these making amount and taking amount functions in any way they would like. So with all of these features in mind, they're all supported by the SDK. So my recommendation is to just use the SDK. And I guess if there's time for questions, please
Yeah,
feel free to reach out.
yeah. Can I ask a quick question here?
Sure.
So you said just use the SDK, but I was told before that once we start customizing the order with extensions and stuff, the SDK will just reject it.
So the SDK is just used to build orders. The API is 1inch's centralized hosting of the orders.
Okay,
And
okay, so
so
that's what you mean. So like we can build and customize order all day long with the SDK, but once we're ready to submit, we need to submit to our own backend that can handle those extensions, right?
correct.
And so like just to qualify for this track, we need to have those like interactions and other extensions that have to be like our own contract deployed there, right?
Correct.
Like we can't just like use like for the call data, I can't just like use the existing contracts that are part of the limit order and kind of combine them.
You could. There are some examples of stop loss and take profit orders, but there are no examples of some of the other ones that I listed. So uh, here. So we don't have any example of like a gas station or vesting payouts or time weighted average price or even grid trading. But we do have an example of stop loss and take profit. Uh, and so if you do want to build this out, you will actually need to build your own contracts, deploy them, and encode the proper order structure.
Yeah, so like just to zoom in on that stop loss and take profit, that alone will, it seems like if it's a stop loss and the position is going to follow the market price, which if it goes up, it's always going to like adjust it. But once it goes down, it's not going to move. But it seems like it's going to require continuous like posting of transactions. I'm sorry, posting of limit orders and canceling the unnecessary ones. So when we cancel, we need to cancel off chain and on chain as well, right?
So cancellations only done on chain. For a trailing stop loss, you may be able to use Chainlink as all the previous rounds have been stored. It might be gas intensive, but you still could.
Yeah, that's what I mean. Like gas intensive. Like if I keep canceling orders on chain, it's going to become very expensive.
Right. So if you wanted to develop a trailing stop loss or trailing take profit, um, you would need to kind of investigate and see what's out there, see if it's possible on chain, and if not, maybe come up with another solution.
Okay, okay, got you. Thank you.
Do you have some working sample code for the usage of SDK JavaScript or Python?
So the SDK is written in Python, or we do have one in Python, but we also have one in JavaScript. And also there's one in Go, in case anyone needs that one. And all of this can be found on our hackathon guide, in case you need it.
Caleb, I was just gonna say, on your Zoom, can you see the chat button?
Yes, I can bring that up.
Yeah, I think just I think you just answered one of those questions, but I think there is just one more there.
All right, let me check. So Remsi asks which SDK, and I would say the limit order SDK, if you're looking at the limit order track. I can send that here. And then I also see, do you have any particular use case you would like to see apart from the ones mentioned? So I don't think all of these have been made at other hackathons. For example, gas station or vesting payouts or time-weighted average price have not been made with extensions in the past. And so I would love to see those myself, but
Wait,
this is kind
could
of open-ended.
yeah, I mean, like, sorry, could you repeat the ones you haven't seen before that you would love to see?
I don't think I've seen the gas station or vesting payouts or time-weighted average price orders with these extensions.
Okay.
I've seen them with basic limit orders, but nothing too in-depth.
Do you see that mostly implemented like on the back end and on chain or with the UI displaying the functionality?
We'd love for you to actually build up a UI displaying the functionality. So that way, users can actually come along and check it out, see how it works.
Cool. And then a follow-up real quick. So when you said that API, like we can use SDK to construct the order, but the API side needs to be, we need to develop one for ourselves. So would something simple like a database table, like a Postgre database table holding orders, and then like a background worker, which will act as our resolver that would constantly check the table to see if any orders are fillable. And then if there are fillable orders, it will go and post an order on chain and it will have its own wallet to do that. Will that suffice?
Yeah, that's enough. I'm not even sure we're requiring actively filling them for the limit order track. But if you just want to use a test net for that, that's perfectly fine.
I have a question about the encoding stuff, like the address encoding and then call dagger. I know like different chains have different like address types, base and whatever. Um, where can I find? I didn't fully like understand that part. So is there like where I can like find more resources to kind of dive deep into this encoding?
So this encoding is kind of it's called ABI packed encoding. And essentially the first 20 bytes of the data is an address, essentially. And this is packed right up next to the rest of the ABI encoded call data. Additionally, for this predicate, you can see the first 32 bytes is a specific value. And so this is kind of like, for example, greater than. The first value is kind of just some static variable. And then the rest of the bytes, so you have 20 bytes, which is your target. And then the rest of the bytes is some ABI call data that is going to go to that target address. This is all handled by the SDK, but if you want to talk more about it, we can. It's just very specific encoding that the limit order protocol supports itself. If you want to use different encoding, feel free to deploy your own smart contracts, and the predicate can also handle those.
Yeah, I'll probably need to ask more questions because I was not really sure like who's using this and like how this like ties together, like what the address is for. So
Yeah, so the target address is primarily for what's going to receive the call data. So for example, your target might be the Chainlink Oracle for Ethereum. And the N bytes is going to be that ABI encoded call data for get latest round data to get the current price of
I
ETH.
see.
Nice. There is 5 minutes left if there are any final questions. A bunch of the AI notes kind of populated the comments, so I'm not sure if we got a couple bumped down, but if you guys do have any further like technical questions, please utilize the Discord. That is the best place to ask these questions because someone from the 1inch team will always be there to kind of help out. Also, the ETHGlobal YouTube will have this exact workshop available for you guys, just kind of right at the top of our channel. Caleb, any final words from you before we end the workshop here?
I don't think so. I'm going to be around in the Discord, both 1inch and ETHGlobal Discord. Feel free to reach out to me. It's Caleb spelled backwards, so BELAC, just like the beginning of this presentation.
Amazing.
And yeah.
Thank you so much for your time, and thank you everybody for attending this workshop. Good luck on all of your projects, and we will see you at the kickoff tomorrow.